Okay, so we're just going to have a look now at the chain rule, okay? And the best way to do this is just to go straight into the examples. I've taken these examples from the book. So these are from page 332 of Active Maths for book 1, and here we go. So this is on page 332, example 13.11. Differentiate this, okay? So we're differentiating this function with respect to x, okay? And we begin by just rewriting the function so that we do not have the square root sign. Instead, what we have is the index format of that, which of course is to the power of a half. Okay. Now, we differentiate this whole function with respect, first of all, to this secondary function in here, which we could refer to as the inside function. Okay, so we ignore what's in yellow there for the first instance. So my f dash x, which of course is the same as dy dx, is a half of whatever is in the brackets to the power of a half minus 1, which is minus a half. Okay, so what it was in the brackets is x squared plus 5x minus 2. Okay, now we have to balance this out, okay? So we have to now multiply it by the diff of the inside function, which is the yellow portion. And when we differentiate the inside function, we get 2x plus 5, okay? That essentially is the differentiation done, okay? Now after that, I look at how to organize this or to express it in a more formal manner. Now this 2x plus 5 does not have a negative index, so it is clearly a numerator. So we have 2x plus 5 up here. We've got a half of, so that's the half being put in there, and this is the negative index, so it would clearly be the square root of x squared plus 5x minus 2. Okay? All right, because it was a negative index, it went in as a denominator, and because it was a half, it got a square root. Okay, so that's your answer there to that one. Okay, right, so we're going to move that on, right, and we're going to again look for the inside and then the outside function. Okay, so the inside function in this case is this one, and the outside function is clearly going to be the 3. So when we go for f dash x on this one, we go 3 times, the 3 is coming from here, what's ever in the bracket, leave it alone, to the power of 2. And then multiply the whole thing by the diff of what was ever in the brackets. And in this case, the diff of 3x plus 1 is 3. Tidy up if you can, so 3 will multiply by 3 to give me 9 times 3x plus 1 to be squared. And that's enough tidying, okay? You could possibly multiply this out for some questions, but definitely not needed in this one. Okay, actually this example is much easier than the first one. So if you rewatch this one, I think you'll get a better handle on the first one then. Okay, and finally then we have this one here, which is very similar to the second one there. We've got 3 has to multiply forward. Whatever is in the brackets is just left alone initially. So the x squared plus 3x to the power of 2. Okay, so we're differentiating what's in the brackets with respect to what's in the brackets. But to balance this, we have to multiply it by the diff of what was originally in the brackets. So of course that's going to be 2x plus 3. So I differentiate this, 2x, differentiate the 3x, and I get 3. Tidy what you can. So multiply the 3 by the linear expression to give me 6x plus 9 times x squared plus 3x to the power of 2. And again, we won't be multiplying that out. That's absolutely fine. It's valid the way it is. Okay, have a look through those a few times, and I'm sure your understanding of the chain rule will improve.